Okay, in this section, I'm going to speak about denial of service and distributed denial of service attacks. We're going to pretty much define what are the difference in between, and then we're going to see what are the identification and mitigation tools. We're going to see that especially the DDoS attacks nowadays are very, very difficult and challenging to stop and requires a lot of resources, which means a lot of, let's say, money invested in order to not prevent, but in order to stop those attacks when they happen. So a denial of service attack, that was clearly the first variation back in the days a long time ago. It's like a simple attack. It's aimed to disrupt network or host or service availability. Usually the attacker is going to source is going to launch the attack from a single system or a very small number of sources. And it's less common nowadays because it's pretty much no longer effective. We're going to speak a bit, of course, about those types of attacks, but we rarely see it nowadays live because it's no longer effective. It's very easy, let's say, to stop this kind of attacks. So in the end, imagine, as I was saying, that you have a web server or FTP server, whatever, and the scope of the attacker is to simply either make sure that the service is unavailable or the host is completely unavailable, so no service on the host, or the network that, let's say, makes your packets reach that service is unavailable. So somehow, in the end, the attacker is going to cause service unavailability in your network. And of course, later on, because this became simple to defend as internet grew up, then they came up with distributed denial of service attacks, which is likewise with the same as the scope is the same. It is aimed to disrupt your network host service availability, but there's a big difference, and the big difference is that usually the attack, and not usually in all cases, the attack is sourced from a large number of sources, too many. And of course, usually because usually those sources are also not aware, they are being used as attack vectors, which means those sources have actually been infected and controlled remotely by the attackers, and those are called botnets. A botnet comes from the combination of the two words of robot and network. So whenever you have a robot in the network, it becomes a botnet. That PC becomes a botnet because it's controlled by a robot, which is the robot of the attacker in the end, so that it is going to do specific actions that the attacker wants the botnet to perform. And of course, it is more and more common nowadays, and it's very effective in nature. We're going to see exactly how it's being developed, and we're going to basically understand why is it difficult to counterattack or to stop this kind of attacks nowadays. And as we're going to see, likewise, it's usually either a more complex attack or it's going to be a mix of multiple types of attacks to reach the point where we end up with a DDoS attack. Now, before we get going to attack types, we have to, we have to define the types of attacks. Those are primarily divided into three types of attacks, both DOS and DDoS attacks. They'll known like to be volume-based, protocol-based, or application-based. Now, at the same time, we're going to see in a couple a Cisco document. An older one is not really updated, but still a good amount of information out there. Cisco uses another categorization for the types of attacks. I personally prefer the volume-based, protocol-based, and application-based of attacks because it makes a more clear distinction between what each attack is supposed to be doing. If we look into Cisco's documentation on that URL, like in here. So Cisco is gonna, in the end, divide the attacks into three other types. They state that we're gonna have what is called, in here on the left side, three DDoS attack general categories, this in here, and they state we have number one, volume-based attacks, number two, application-based attacks, and number three, low-rate attacks. Now, let's first define what I was saying about the other categorization, volume-based, protocol-based, and application-based, and then I'm going to get back here to see there's not much of a difference, but for me it makes much more sense to use the other categorization of attacks. But of course, you got to be aware also of the Cisco categorization. In the written exam, you may get questions on the top. You got to know how Cisco ends up categorizing those. So let's start with the first option, volume-based attacks. What happens, per the name, victim is flooded with a high volume of connections and or packets. Depends which one, of course, is more effective. Depends of the connection type or packet type. Which one is more effective to flood the victim. That's what's going to be used. Either more connections or more packets. Now, in the end, the attacker's scope is to saturate the bandwidth of the victim's network. That's why it's called volume-based. And it is the, let's say, the successful or unsuccessful rate of the attack is going to be measured in bits per second. So pretty much the more bits per second we end up sending towards the victim's network, the more successful the attack is. Couple of examples. So the classic, let's say, initially back in the days, the ICMP and UDP floods. So somehow we're going to generate a huge amount of those packets because they are connectionless. They don't need a connection to be pre-established, and it's easy to send those packets towards the victim. And we're going to end up, as we said, consuming the whole bandwidth of the customer facing, let's say, the internet. Now later on, because those were basic attacks, as internet grew up, we evolved to what is called an NTP and or a DNS reflection amplification attacks. Those are just two use cases, but the let's say next generation of volume-based DDoS attacks is going to be the ones which are based on reflection and amplification. So before we see such examples and what they mean, let's speak again about this volume-based network attack and to make sure that everybody is aware of exactly how this works. So imagine that, for example, we're going to take, let's take an example here from Cisco's document. I'm not sure if they have a cloud or something in here. Either we can go upstream and stop somewhere here to one of the attacks and make use of that diagram in there. So imagine looking here on this diagram. So imagine that this is the customer, which I'm going to put it in red in here. The victim. This is going to be the victim. And the victim's internet connection, so the WAN connection, is going to be clearly this way. So that's going to be the WAN link. And for example, the victim may have to the internet, whatever, let's say it's going to have 10 megs per second. So this is how much this customer has paid, this internet customer, he's paid for 10 megs per second. So pretty much what this means is that the attacker's scope, which is going to be here, the attacker, this guy over here, is to send enough traffic towards the customer's network, so to reach the last mile, to make sure the traffic reaches the first hop of the customers towards the internet. I need to make sure I send more than 10 megs per second, so more than 10 megs per second of traffic in order to saturate the customer's bandwidth facing the internet, which is going to in the end make the service totally unavailable from the internet to legit customers or legit users, because there's not enough bandwidth. So usually in the end also the provider is going to end up dropping a lot of traffic heavily because it's going to police it and rate limit it, and because the customer has paid only for 10 megs, not more than that. As I was saying, later on, that was easily achieved via UDP, ICMP floods. We're going to speak about those later on. We'll just give examples in here. But then they came up with those reflection and amplification attacks. Now, a reflection attack, as the name implies, what happens is the attacker is gonna spoof the victim's IP address. We're gonna see how this works exactly. So the attacker chooses a victim. He's gonna spoof the IP address of that victim, and then the attacker is gonna initiate a large amount of requests with that spoof source towards a destination from the internet, whatever destination is. And then that destination, that responder is going to reply back to the victim, not to the attacker, because the attacker has spooked the victim. So that the legit responder is going to then reply to the victim, flooding it and causing a distributed denial of service, because the victim is going to receive a lot of unrequested replies to whatever the attacker was querying about. And then the amplification attack is nothing else but an enhanced version of the reflection attack, which was the difference is that not only is based on this reflection because of the spoofing because the attacker spoofs the source of the victim, but also what happens is that the attacker's requests will force a large or a big reply from the destination he's reaching out to, which means that the reflection attack is more, let's say, effective because the replies are bigger and bigger, which means the attacker is going to easier and faster consume the victim's bandwidth and end up with a very fast volume-based DDoS attack, which is successful. So for example, we have an example here on this Cisco document. They speak about the DNS amplification attack. So let's understand exactly here what happens. Because this is, in the end, as I was saying, that the amplification attack is a better version, the enhanced version, and the reflection attack. That's the main, there's the only difference in between. So here we have, I'm going to put with red to be the attacker. So we have in here on the top left side, we have the attacker in here, which what the attacker does, it is going to spoof its source IP address to be, let's say source IP is going to be whatever, 1234, let's say, if it's IPv4 or it's IPv6, whatever IPv6 address, where actually that source IP belongs to the victim in here. So actually this victim, this server on the bottom, actually has the real IP to be that 1234. So then the attacker spoofs that victim's IP address of 1234, I'm going to use the color of blue next, and sends a large amount, speaks with, via the command and control center, speaks with some compromised machines from the internet. Those will be our botnets, usual, let's say, computers, or nowadays IoT devices, Internet of Things devices, which somehow got compromised and they are controlled remotely by the attacker, so they became a botnet. So then the attacker speaks with those, sends instructions to those compromised machines to actually generate packets, in this case DNS queries, with of course spoofing the source address to be the victim. So all this DNS queries to the DNS servers, this DNS queries, a large amount of them, DNS queries, have a source, a spoofed source of that 1234. So what happens is that this DNS query goes to what they call open recursive servers, because that's what also facilitates this kind of attack. DNS queries goes to open public, let's say, DNS servers from the internet. Then what happens is, because those DNS servers, they don't actually, let's say, own that domain name, they're going to pretty much end up forwarding the request which they got from the compromised machines, step number 2. They forward the request, step number 3, to the name server or the DNS server which actually owns that domain, whatever the domain query was about. And then what ends up happening is that when the server replies, step number 4, the server is going to reply to the destination IP of 1234. So the server receives a huge amount of queries, and then when the server replies to that destination IP of 1234, which means the reply actually gets to the victim. The victim, of course, has never actually queried about that domain or whatever, but the reply gets to the victim. And in this case, they call it the amplification attack because the query was done in such a way that the reply, so this step number 4, the reply was had a large payload, which made this attack to be not only a reflection attack, but an amplification type of attack. Now, why is this called reflection in general? Because what I'm doing is like a mirror. What happens is somehow the attacker, if you think about it, the attackers send some packets to this server, to this name server, which then behaves like a reflection, like a mirror, because when that server replies, the replies go to the victim. So that's why it's called a reflection attack or a mirror attack, based on how it works, and it's pretty much based on spoofing the source of the packets that the attacker sends to whatever destination on the internet. I'm going to speak in a couple of minutes about some examples of amplification attack to better understand how they're actually working, how they are based, but this is the base functionality of it. Now, then we have what we call, as I was saying, protocol-based attacks, which means the victim is flooded with, again, a high volume of connections and or packets, depending which one is more efficient. And this time the attacker's scope is to consume the actual servers or destination's resources or network equipment resources. So the scope is in here is not to consume the whole bandwidth, it's not volume based, but the scope is now to make sure that that individual service or the path to that service becomes unavailable, is no longer reliable or functional. So this kind of attack, it's measured in general in packets per second, because the scope being to overload the actual destination, the server, it means that I need to send a huge amount of packets per second to make that server, crash or being overloaded and make the service unavailable. And as I was saying, based on if the network design was not done correctly, it can happen that before I actually overload or consume the resources of the destination server, I may end up consuming the resources of a firewall or a balancer, which actually sits in between the attacker and the victim. But maybe that firewall, that balancer has not been properly, not properly sized, which means the firewall, the balancer is going to end up without resources faster than the actual target of the attack, which was the server. Which of course, if you make the network path towards the server unavailable, implicitly the attack is successful because the service is unavailable in the end. A couple of the examples are going to be TCP SYN floods, IP fragmentation attacks, ping of death. I'm going to speak about each of them. They should be intuitive by the name. I'm going to generate an attack using a lot of SYN packets, or we're going to speak in detail about the fragmentation part of both IPv4 and IPv6, how those attacks are successful and why, and the ping of death, which is nothing else but a variation, let's say, of a fragmentation attack. Next, we have what is called application-based attacks, which means the victim this time receives legitimate requests that are aimed to exploit protocol or application vulnerability. So as opposed to the previous attacks were both volume-based and protocol-based, were pretty much not, in general, were not, let's say, valid end-to-end sessions. Like the reflection attack or the amplification attack was, let's say, a valid, let's say, DNS request, DNS reply, but because of the spoofing of the source IP address, the request and the reply were not actually between the same two hosts. So that was not a valid session. So application-based attacks, so those kind of attacks, volume-based or protocol-based, are in general illegit or malformed sessions, which are going to end up creating a DDoS or a DoS attack. While application-based attacks are in general articulated based on legitimate requests, so there's nothing wrong at layer 3 or layer 4. It's a regular, let's say, connection between two hosts in the world, but there is something wrong at the application layer, layer 7, which usually what's going to be wrong is the attacker makes use of a vulnerability in the protocol or a vulnerability in the application that's running on that server. And in the end, based on those type of packets which are being sent in the attack, it's going to end up making the server or the service allocate maximum resources per request. So this is the scope in here, because if you think about it in the volume-based attacks, I need to send a huge amount of packets or a huge amount of sessions to overload, to flood, to eat up the whole bandwidth. So that was the scope in there. But in here, what I need to do is I need to send a few, very, very few packets to look, as legitimate as possible. So not only the requests and the replies are legit, let's say, legit packets back and forth, but also I want to minimize the number of packets I'm sending, because I don't want it's to be obvious it's a denial of service attacks. But even if I'm sending very few packets, I try to maximize the outcome. So I try to somehow make the service or the application allocate like tons and tons of resources for even a small request to the application. So that's why this kind of attack is measured in requests per second, and usually it's like a low rate attack. It's not too many requests per second, but it is, let's say, some kind of a request which is, I was saying, are exploiting a protocol or an application vulnerability and end up achieving the same thing. So I think examples would be low and slow attacks. This is one of the categories that Cisco has done in their DDoS attack categorization. So slow attacks like HTTP GET or post floods. We're going to speak of examples in a couple. Now in DOS or DDoS mitigation, we always have two steps. So we need both of them in order to let it be secure. In general, as I was saying, you're going to end up seeing that in most cases we are going to be under attack for a while. The challenge nowadays is to stop it as fast as possible. There's really not a lot of, let's say, very good DDoS attacks. It's close to impossible to prevent them. But what it is possible is to detect them fast enough and then stop the attacks from happening. But it is gonna happen for a while out there. So as I was saying, we have two steps in there. We have to identify the attack. We got to be aware that the attack is happening as fast as possible. The sooner the better. And then once we are aware of that, we have to end up trying to mitigate the attack using manual tools or automatic tools in there. Of course, automatic tools would be preferred, but in the end, you have to make a cost decision because clear automation tools are going to be more expensive. Now we're going to again look back to Cisco's document in there and speak about the identification of the attack and mitigation of the attack.